Amazon RDS, or Relational Database Service, makes it easy to set up, operate, and scale a relational database. Today, it supports Amazon Aurora, PostgreSQL, MariaDB, Oracle, MySQL, and Microsoft SQL Server. It reduces the administration burden of running your own database by automating patches and backups. Supports snapshots for redundancy and multi-AZ deployments for high availability. I mentioned Amazon Aurora in the last slide. Amazon Aurora is an enterprise database built to natively take the advantages of the elasticity in the cloud. Today, it supports MySQL and PostgreSQL out of the box. It is up to 5 times faster than the standard MySQL and 3 times faster than the standard PostgreSQL databases. Amazon Aurora features a distributed, fault-tolerant, self-healing storage system that automatically scales up to 64 terabytes per database instance. It delivers high performance and availability with up to 15 low-latency read replicas, point-in-time recovery, and nearly continuous backup to Amazon S3, and replication across 3 availability zones. The database offering we have discussed were primarily focused for relational workloads, which has a fixed schema. With the wider adoption of Internet in early 2000s, there has been a tremendous growth in variety of datasets being generated with changing schema, and single instances were not able to handle the request. And hence, the need for newer databases that can help accommodate those application requirements. The not only SQL or NoSQL databases help meet those requirements. Amazon DynamoDB is a fully managed, fast, and flexible NoSQL database. It is built for low latency, with the average service-side latency typically in single-digit milliseconds. As your data volumes grow and application performance demands increase, DynamoDB uses automatic partitioning and SSD technologies to meet your throughput requirements and deliver low latencies at any scale. DynamoDB is used in many places today, such as serverless web applications, microservices, mobile backends, ad tech, gaming, and IoT or Internet of Things. In addition to what we have discussed, AWS also has services for data warehousing, such as Amazon Redshift, graph data, such as Amazon Neptune, and for MongoDB compliant workloads, Amazon DocumentDB. To help you move data, we have AWS Database Migration Service, or DMS, which makes it easy to migrate databases to AWS quickly and securely. Today, AWS DMS supports homogeneous migration to the same database engine as well as heterogeneous migrations for different databases. There are many options in AWS for database today, and not one works for everything. If you need an enterprise-class relational database, choose Amazon RDS. If you need a fast and flexible NoSQL database without need to scale, use Amazon DynamoDB. Need full customization? You can always run your own database in Amazon EC2, as well as specific case-driven database for machine learning, data warehousing, and graphs. Automate deployment. AWS CloudFormation is a service that makes it easy to create repeatable, deployable models of your infrastructure, allowing you to capture your infrastructure as a code or templates. First, you code a template describing your infrastructure. In this case, it would include our VPC, subnet, internet gateway, and security for your network, and a single EC2 instance to run our application. Going back to our original application, a simple web application hosted on an EC2 instance backed by S3 and EBS for static content and database storage. We can replace EBS volumes or database component of our application with Amazon RDS to get better performance and reduce administrative overhead. To take advantage of the elasticity of the cloud, we can use Amazon CloudWatch, elastic load balancing, and auto scaling to get better scalability. Finally, we can capture this design by creating a CloudFormation template so we can redeploy the same architecture again if needed. Does all that sound complicated? Want a simple way of doing same things? For certain workloads that fit a two-tier architecture, AWS Beanstalk makes it simple to set up and deploy web applications on AWS. You just give AWS Beanstalk your code and it handles all the details of infrastructure provisioning, high availability, load balancing, and monitoring. This allows you to focus on your application. Connect and share data. Do you have an on-premise data center and need a way to connect it to AWS to either extend your capacity or migrate your workloads? Connecting it over the internet has limitations, such as network, storage, and communication challenges. AWS Direct Connect is a dedicated network connection from your premises to AWS. It provides fast and private connectivity to AWS. How does AWS Direct Connect work? We have various Direct Connect partners across the globe in which we have deployed AWS Direct Connect infrastructure. You can provision a fiber connection to our partners who connect you to AWS Direct Connect, allowing you to bypass the internet and get a faster and more reliable path to AWS services. Amazon Route 53 is a highly available and scalable domain name system web service. You can use it today to register domain names, route internet traffic to resources based on geolocation, weight, etc., and also do health checks. Here is an example how we can use Amazon Route 53 to host our domain sales.example.com and route it to our application hosted on EC2 instances behind an elastic load balancer. Amazon EFS, or Elastic File System, is a fully managed, scalable, elastic cloud-native file system for Linux. EFS scales for you so you don't have to worry about data limits or performance, making it easy to implement a shared file storage. Continuing with our web application before, instead of all our application data stored on EC2 instances, we can now centralize it by storing it on EFS with connectivity through Direct Connect to the on-premise resources. Bringing AWS on-premises. AWS Outpost is a fully managed service that extends AWS infrastructure, AWS services, communications network. Migration, VM template migration, or even while the workloads are running through live migration, that is vMotion. With bare metal Amazon EC2 instances available in VMware Cloud on AWS, you can get full access to the Intel Xeon processors powering your workloads. They are available in variant i3 Metal and R5 Metal to suit different workload requirements. One of the key storage technology that VMware Cloud on AWS supports is vSAN, which is hyper-converged software-defined storage that pools together direct attached storage devices across VMware vSphere cluster to create a distributed shared data store. This allows customers to have an option for more cost-effective deployment, especially if they have storage-intense workloads. Deliver content faster. In this example, rather than improving an existing environment, you will build cloud-native architecture. The requirements for your solution are shown in this diagram. You can meet most of these requirements by using AWS services that you have already learned about. But there are additional services in this topic that will make your architecture faster, more scalable, and more cost-efficient. You can use AWS Lambda to run code without provisioning or managing servers. You only pay for when your code is running. You upload your code, Lambda takes care of everything required to run, such as scaling and high availability. AWS Lambda is an event-driven service, allowing you to automatically trigger from other AWS services, or you can call it directly from any web or a mobile application. AWS Lambda supports Java, Node.js, C#, .NET, Python, Ruby, PowerShell, and custom languages using Lambda layers. Lambda deals with the administration, tolerance, and orchestration, allowing you to focus on your code and application. Here's an example of how we can use AWS Lambda to process and generate thumbnails for images we upload into S3. We can configure S3 events to trigger AWS Lambda functions, which can be a code we deployed to generate a thumbnail. The execution role here gives permission for our AWS Lambda function to talk to Amazon S3. What services can trigger AWS Lambda? One service is Amazon SNS, or Amazon Simple Notification Service, which is a broadcast or a pub/sub service that allows you to reliably send messages to other systems such as Amazon SQS, AWS Lambda, as well as HTTP endpoints, emails, SMSs, and mobile push notifications. Amazon SNS will manage scaling and the infrastructure required. You just focus on how to configure where your message needs to go. How does Amazon SNS work? To configure Amazon SNS, we first need an Amazon SNS topic, which is a channel we use to map our producer or publish to our consumers or subscribers. Whenever we publish a message to an Amazon SNS topic, Amazon SNS will then send out that message to any subscribers of that SNS topic itself. Amazon CloudFront is a fast content delivery network that you can leverage to quickly and securely deliver content around the world. It integrates with AWS Shield, our DDoS mitigation service, and supports Amazon S3, ELB, or Amazon EC2 as origins of your content. Today, Amazon CloudFront has 205 edge locations around the world you can use to accelerate your distribution of your content. When a user requests for content, without a CDN like CloudFront, it would mean the request going to the origin. For instance, a customer in Singapore making a request for the services hosted in Singapore would get media relatively quickly. However, if they make the same request from Japan, the content has to travel much farther on the internet to reach them. What CloudFront allows us to do is, instead of going across the internet, we can go to the nearest edge location. So, in the last scenario, instead of our customer in Japan going to Singapore to get their content, they would now go to the CloudFront edge location in Japan. CloudFront is a lazy loading caching system, meaning that it will only load the content into the edge location when it is requested. Therefore, for our use case, for the first time our customer in Japan asks for the content, it won't be loaded in the Japan's edge location. CloudFront would load it behind the scenes or populate that cache and then serve it, meaning it will be ready for any subsequent requests. Let's demonstrate just how much CloudFront improves performance. So we have talked about how we can use CloudFront to accelerate access to our content. In the last module, we showed a demo of an S3 static website. Now let's go and make access to that website a lot faster using CloudFront. So we are back in the AWS Management Console and we can search for the CloudFront service. In the CloudFront Management Console, we already have a CloudFront distribution configured to serve a static website. Once we click on the distribution, we can see the configurations that are used to create the distribution. CloudFront also generates a domain name that can be used to access the original content. We can copy the domain name and go to the Origin tab. In the Origin tabs, we can see the path of files we want to cache. Here we have static websites, so let's see how CloudFront enhances the performance by reducing latency for that static website. Right now, this website is being served from an S3 bucket. On the side, we can see how much time it takes to load the website. When we refresh, we can see that it takes 584 milliseconds to fulfill this request. Now let's see how fast it loads up with CloudFront. In another tab, we have that CloudFront domain, and if we refresh to see how fast this one loads up, we can take a look that it took just 127 milliseconds. So instead of serving the request from North Virginia, where the static website is hosted, it can be served from an edge location near to the user. Amazon Elastic Cache is a service that makes it easy to deploy, operate, and scale an in-memory data store, making it easy for developers to set up in-memory infrastructure to accelerate their applications. Today, you have options between Memcached, which is created for applications that need a cache that supports large amount of concurrency, and Redis, in which you need data persistence and more advanced data types and features. How can we put the services we have discussed together to build a media streaming service? To process and prepare our media to deliver, we can use Amazon S3. To create and ingest, we can use another S3 bucket to store and trigger a workflow whenever new content is uploaded. That workflow can be powered by AWS Lambda, which will extract metadata and store it in DynamoDB, sitting behind Elastic Cache for Redis to enable faster search. To process the content for delivery, we can set up an SNS topic that delivers messages to the multiple subscribed AWS Lambda functions, which will transcode our video from the source format to high-quality 480p, 360p, and audio-only formats. These are then stored in a playback S3 bucket behind CloudFront for faster delivery to our clients. In summary, we have talked about various cloud-native or serverless services you can use to build your applications, like Amazon CloudWatch for monitoring and metrics, ELB and auto-scaling to achieve high availability and cost optimization by scaling out when we need more and scaling in when we don't. AWS Data Services to store our data such as RDS and DynamoDB, AWS CloudFormation and AWS Elastic Beanstalk to automate infrastructure deployments, AWS Direct Connect for faster, more reliable connectivity to AWS data centers, Amazon Route 53 for DNS hosting, AWS Lambda to run code without managing servers, and finally, Amazon CloudFront for content delivery. So thank you for your time, and do remember to test your knowledge for this session.
You have an application composed by individual servers in a rollout are requested by servers based on the connect.
Hello, my name is Navjot, and I'm a technical trainer based in Sydney, Australia. The topic we will be discussing is security, which is an important topic for all customers. Today, we will show you the best practices on how to create secure environments by utilizing AWS security services. We will also be learning about the AWS Shared Responsibility Model. You can access these services directly through the console, CLI, SDK, or APIs. The first aspect of security we will focus on is securing your infrastructure. Security is a top priority in AWS. The AWS infrastructure has been architected to be one of the most flexible and secure cloud computing environments available today. It is designed to provide a scalable, highly reliable platform that enables customers to deploy applications and data quickly and securely. The security services AWS offers allows customers to monitor their environment and allow security issues to be rectified in an automated manner by utilizing API integration services. Services such as AWS Config can monitor AWS resources to track configuration changes and can automatically remediate its findings to improve upon the security posture of your environment. For example, if an administrator allows SSH to the world in a security group, AWS Config can remediate this automatically. The platform itself has been built with high availability in mind to eliminate single points of failure. The AWS Global Infrastructure is highly accredited, and we discuss later in this module the industry standard compliance program AWS is compliant with. Examining the AWS cloud, you will see that the same security isolations are employed as you would be able to find in a traditional data center. These include physical data center security separation of the network, isolation of the server hardware, and isolation of the storage. We have a shared responsibility model with the customer. AWS manages and controls the component from the host operating system and virtualization layer down to the physical security of the facilities in which these services operate. This is what we call security of the cloud. In the previous slide, we talked about how AWS is responsible for security of the cloud. The customer is responsible for security in the cloud. What this means is AWS customers are responsible for building secure applications. We provide a wide variety of best practice documents, encryption tools, and other guidance our customer can leverage in delivering an application-level security measures. In addition, AWS partners offer hundreds of tools and features to help customers to meet their security objectives, ranging from network security, configuration management, access control, and data encryption. For example, if a customer has a security requirement to implement encryption at rest on their EBS volumes, customers are responsible for configuring EBS to use KMS encryption keys to meet this requirement. If we put the two parts we have just discussed together, that is security of the cloud and security in the cloud, this forms the AWS shared responsibility model. AWS operates under this model. An easy way to remember how this works is to think of it like this. Anything you cannot see, touch, or change is AWS responsibility, security of the cloud. For example, customers do not have access to open our EBS storage racks. Therefore, the physical and logical security of EBS belong to AWS under the shared responsibility model. Anything a customer can see, touch, or change is customer's area of responsibility, security in the cloud. For example, customers have full access to their EC2 instance operating system. So the customer is responsible for patching vulnerabilities within the operating system. AWS has a full suite of security services that customer can leverage in their environments. The three security services we will focus on today is AWS IAM, Identity and Access Management, Amazon Inspector, and AWS Shield. When it comes to the two A's of within AWS account, the services which manages these is IAM, which we will discuss in further detail. IAM is a service which controls who can authenticate to an AWS account. This can be done using a number of options within an IAM console. The first option is IAM users. IAM users can be created, and we can authorize what actions an IAM user can perform inside the account. We can also create IAM groups and place the IAM user inside the group. We can then authorize what actions the group can perform inside the account. This removes some of the administrative burden of having to manage authorization at an individual IAM user level. The last option which can be used are IAM roles. And we can authorize what actions the IAM role can take inside the AWS account. IAM roles are unique in that they provide temporary credentials that can be used to access AWS resources. The IAM role can be assumed by IAM user, and at AWS services such as EC2 or Lambda. This means we do not need to hard code our credentials inside our application. On the EC2 instance itself, IAM roles can also be used by other AWS accounts or cross accounts access and federated identities to allow existing identities from our corporate Active Directory to access AWS resources. IAM users can access AWS via three methods. The first is AWS CLI, the command line interface, typically used by system administrators. AWS SDKs, the software development kits, typically used by developers, and the AWS Management Console, used when customers prefer to use a simple GUI. Each one of these access methods requires an IAM user to be authenticated before they can access the AWS resources. After the IAM users authenticates to AWS, how do they control what they have access to? This is done via an IAM policy. An IAM policy is a document, typically written in JSON, which determines which service and what access to those services an IAM user has. As mentioned earlier, an IAM role can be assumed by IAM users, AWS services, and other AWS accounts and federated identities. The IAM policy is assigned to an IAM role, which determines what role does or does not have access to the inside AWS account. In this scenario, the application on the EC2 instance wants to access the S3 bucket. By default, the EC2 instance has no credential to access the S3 bucket, so access is denied. First, we create an IAM policy or use a template policy to determine what we want the EC2 instance to have access to. After the policy is created, we then create an IAM role. Next, we associate the IAM role directly to the EC2 instance. After we do this, the EC2 instance can access the S3 bucket, and IAM policies determines which action EC2 instance can take on the S3 resource. Though the whole process, the EC2 instance does not have any credentials hard-coded, and the IAM role ensures the temporary credentials assigned to the EC2 instance are rotated on a regular basis. In this demo, we will visually explain the IAM concepts using a virtual blackboard. The root account is the first account created, and has full access to the AWS account. We recommend the following best practices to secure the root account. Enable a strong password, enable multi-factor authentication, IAM supports hardware and software tokens, and delete the root access keys. At the heart of IAM are IAM policies. There are two types of IAM policies, which are AWS managed and customer managed. An IAM policy specifies what a principal has access to or has been denied access to. IAM policies can be assigned to different principals later. One type of principal is an IAM user. An IAM user can authenticate to the AWS account in two ways: via the console using a username and password, or via access keys using the AWS SDKs or CLIs. One or more IAM policies can be applied to the user. Assigning policies directly to users can be an administrative burden. IAM also supports groups. Groups can be created based on roles users perform. Users can be added to the IAM group, and IAM policies can be assigned directly to the group rather than each user. This makes administration a lot easier. Another type of principal is an IAM role. Think of an IAM role as a hard hat that other AWS services can put on. Our EC2 instance is going to put on this hard hat or assume this role. By assuming a role, the EC2 instance is granted access as per the IAM policy assigned to the role. In this example, the IAM policy provides read and write access to the S3 bucket. Behind the scene, there is a service called STS, which powers IAM roles. This service issues temporary credentials. Rotate the temporary credentials and assign a time to live for our temporary credentials. Here is a summary of best practices we recommend when it comes to security in IAM. I have discussed some of these best practices already. I'll pick out a few to highlight. Use the principle of least privilege. Only grant enough to access for users to complete their tasks. Do not assign anything more or less. Whenever possible, use IAM roles so we don't have to hard code any credentials in our instances or in our application code. Rotate your credentials. IAM supports password policy changes, and access keys can be also recreated. Lastly, monitor activity in your account. Use services like CloudTrail to keep track of all the API calls made in your account and store them in an S3 bucket for traceability. Access your security and compliance. Performing threat assessments inside an environment is not an easy task. Most tools are costly, and configuration and maintenance takes time. Is there an AWS managed service that can assist and perform a lot of the heavy lifting for customers? Amazon Inspector can help with performing threat assessments in your AWS environment. It automatically assesses applications for vulnerabilities or deviation from best practices. After performing the analysis, Inspector will produce a detailed security finding report, which is accessible from the AWS Inspector console or via an API. Amazon Inspector includes a knowledge base of hundreds of rules mapped to common best practices in security. And these rules are regularly updated by AWS security researchers. Inspector leverages an agent installed inside the EC2 instance to perform the threat assessment. This makes it easy to build as a part of your DevOps deployment process. Here is an example of inspector findings after a scan. Findings are potential security threats. Each finding will contain a detailed description of the security issue and the recommendations for the resolution. Some of the details provided include name of the EC2 instance where the finding was registered, name of the template used to produce the finding, assessment start, end time, severity of the findings and remediation steps. Here's an example of a finding and remediation actions. As you can see, inspector details the finding and then provides detailed remediation actions. In this particular case, it is recommending to prevent root logins over SSH. In this section, we will discuss the AWS service which protect against distributed denial of service attacks. When a DDoS attack occurs, an attacker is trying to flood your website to cause an outage. The attacker typically uses multiple sources such as compromised computers, infected with malware from various locations around the world. The attacker can attempt to exhaust compute or bandwidth resources to your website to take it down or make it unavailable to legitimate users trying to access your website. DDoS mitigation is a complex task. It is not something that can be quickly set up on-prem. There are challenges around provisioning enough bandwidth. It may require re-architecting existing solutions and can be costly to implement and maintain. AWS Shield provides DDoS protection out of the box for customers as a managed service. The service is also on and is free when customers use services such as ELBs, CloudFront, and API Gateway. It does not require any re-architecting to existing application and leverages our highly available, secure global infrastructure. As mentioned, entire Shield standard is a free service that protects all customer provided. They are using services like ELB, CloudFront, and API Gateway. With Shield Advance, there is a cost associated, but there are a number of benefits to customers such as specialized support from a dedicated DDoS response team and cost protection. With Shield Advanced, customers have access to a DDoS response team 24/7 that can assist customers when they are under a DDoS attack. With cost protection, any cost a customer incurs due to a DDoS attack, for example scaling out, AWS will cover the cost. In the next section, we will look at assurance program that AWS is compliant with. Here is a sample of the assurance programs that AWS is compliant with. These are the industry standards, programs, and some customers may already be familiar with, such as ISO, SOC, IRAP, and furthermore. Customer can access the AWS compliance page to get further details on each program and how AWS is compliant. To assist customers achieve compliance, AWS ensures the underlying platform is compliant and provides proof of compliance via attestations of compliance provided by third-party companies. Let's take PCI, Payment Card Industry Standard, as an example. Many AWS services are PCI compliant, but customers are responsible for making sure their application code is PCI compliant. AWS and customers shares the responsibility when it comes to compliance as well. Let's take a look at a demo for AWS compliance. Customers can navigate to the AWS Compliance Programs page to see the various programs AWS is compliant with. Scrolling through the page, there are global programs as well as country and region-specific programs. By clicking on one of the programs, we can access more information. For example, let's have a look at PCI DDS Level 1. But what if we need to provide an artifact to an auditor to prove that AWS is PCI compliant? Do we need to engage AWS to obtain the necessary evidence? This can be resolved by customers directly via the AWS console. Customers can access the AWS Artifact service. This service allows customers to download the PCI attestation compliance reports where reputable third-party companies have verified AWS is PCI compliant. This document can be provided to the auditors. Remember, AWS operates under the shared responsibility model. Customers are responsible for owning their own certifications. While AWS can assist with the infrastructure and AWS services compliance part of the equation, customers are responsible for reviewing, designing, identifying, and verifying they are compliant with their requirements. Thanks for watching Module 4. Now is probably a good time to take a quiz and check your knowledge. In this section of the course, we will discuss AWS pricing models, some pricing tools, and lastly, AWS support options. Fundamentals of pricing.
Requires AWS connection or
This slide
use
shows some of the
AWS
ways
services.
customers can pay for AWS services.
quantity you should
Let's dive a bit
use.
deeper into each one of the topics shown.
Give the following are best
One of the
practices
many
to stick to them.
advantages of
Firstly,
AWS is the pay-as-you-go pricing.
use the simple
In the on-prem world, there was a risk of over-provisioning capacity or under-provisioning capacity. With the cloud,
updated
customers pay
sequence
for resources as they consume them. This removes the headache
Great.
of capacity planning and allows customers to focus on their core business. It is similar to how consumers flip a switch to turn on a light in their home and their power companies send electricity.
key.
With certain services like EC2 and RDS, customers can invest in reserve capacity. With their workloads needs are long-running, known, and predictable. There are few payment options available to consumers, which are all upfront, partial upfront, and no upfront payments. The biggest advantage to customers is if they reserve their capacity between 1 to 3 years, they receive a discount over the on-demand price of up to 75% depending upon the payment method they choose. With AWS, customers get automatic volume-based discounts for certain services. An example of this is S3, the simple storage service, which uses tiered pricing. What this means is that the more customers use S3, the less they pay per GB a month. Another example of automatic volume-based discount is data transfer out of an AWS region. The more data customers sends out of the region, they pay less per gig a month. There are three fundamental pricing concepts for AWS services. For compute resources, they are billed by the second for Amazon Linux OS and Ubuntu, and per hour for Windows operating system. Note that any operating system, such as Red Hat Linux, which requires a license, is also billed by the hour. Storage costs are relatively straightforward and typically charged per GB provisioned. Generally speaking, any data transfer into AWS, there is no charge. There is a charge for outbound data transfer, and the charge is typically done on a per GB basis. We recommend consulting the AWS documentation for the most up-to-date information on the pricing per service per region. Different services are priced differently. Let's dive into some of the services listed to see how pricing works. With EC2, there are 4 purchase types. The first is on demand. This is the default option if customers spin up an EC2 instance or virtual machines. As explained earlier, the pricing is done on a per second or per hour basis depending upon the operating system being used. The second type is reserve instances. Customers can receive up to 75% discount over the on-demand pricing when they commit for a 1 to 3 year period. The third option is dedicated hosts. These are physical servers dedicated to customers. They are typically used when customers want to BYOL into AWS. The fourth option is spot instances. Customers can pay for spare AWS capacity and receive up to 90% discount over the on-demand price. This is a great option to gain access to large amounts of capacity at a heavily discounted cost. Let's take a look at a demo how spot pricing works. In this demo, we will visually explain what spot instances are. Here we have a basic graph to illustrate example compute capacity in an availability zone. Along the x-axis, we have time, and y-axis, we have capacity. Capacity planning for reserve instance is fairly simple. Customer commit for 1 to 3 years and receive up to 75% of savings over on demand. In the graph, reserve instance capacity is growing at a steady rate, The on-demand instance usage is determined by AWS customers' usage, will go up and down based on the customer demand, and is illustrated in the graph. Provision capacity is the amount of compute capacity within the example availability zone. Here we have highlighted the spare unused capacity. Customers can enter their max price for spare capacity in the spot market. AWS controls the spot price based on the spare capacity in the availability zone. Spot instances provide a steep discount of up to 90% over on-demand price. However, customer can lose this capacity if AWS needs the capacity back. Let's take a look at scenario of how this works. In scenario 1, there is a lot of spare capacity. Let's assume the instance we want at spot is normally at $1 in on-demand price. Customer launches a spot instance and enters a max price of 30 cents. The current spot price is 27 cents, which means the instance launch is successful. The customer's max price exceeds the spot price, so they will get the instance at 27 cents per hour. But what happens if the spot price goes up? In scenario 2, there is less spare capacity available, so the spot price is raised to 70 cents. The spot price now exceeds the customer's max price of 30 cents. The customer is given a 2-minute warning via CloudWatch events and instance EC2 metadata URL. After 2 minutes, the instance is terminated, stopped, or hibernated depending upon the configuration the customer has set. EBS volumes are charged by gigabyte provisioned a month, but price does vary depending upon the type of EBS volume selected. For example, 100 gigabyte provision IOPS volume will cost more than 100 gigabyte general purpose volumes. To back up EBS volume, EBS snapshots are used and stored in S3. Pricing for snapshots is charged by space consumed in S3. There is also a charge if an EBS snapshot is copied across regions. Lastly, don't forget the AWS data transfer out aspect. If your application transfers a lot of data outbound to the internet, there is a charge for this. S3 pricing is determined by 3 factors. First is storage. The amount of storage used will change the price as well as the storage type. For example, S3 standard storage costs slightly more than the infrequent access storage. Second is the number of requests and type. For example, there is a charge for GET, PUT, and copy requests. Third is data transfer out. Any data transferred out of the region from S3 This pillar focuses on the ability of system to recover from infrastructure or service disruptions. Some design principles test recovery procedures, automatically recover from failure, scale horizontally, and manage change in automation. Performance efficiency. This pillar focuses on the ability to use computer resources efficiently. Some of the design principles are democratize advanced technologies, serverless architectures, and experimenting more often. Cost optimization. This pillar focuses on the ability to reduce underutilized resources and/or suboptimal resources. Some of the design principles are use managed services, adopt a consumption model, measure overall efficiency, and analyze expenditure. This is an example of a reference architecture which focuses on reliability pillar of the well-architected framework. This is a typical three-tier web architecture that is made highly available by using the Elastic Load Balancer service. If a web server goes down or an availability zone, the load balancer can distribute load to the healthy backend instance to ensure uptime for the web application. By inserting a load balancer into this architecture, we make the application highly available and resilient from single point of failure. Here is another example architecture that builds on the previous basic three-tier web application. Let's walk through this together, following each of the numbers. Users' DNS requests are serviced by Amazon Route 53. This is a highly available DNS service that runs in more than 200 locations around the world using AWS Edge locations. AWS Content Distribution Network, which can cache object closer to the end user to reduce latency. This service also leverages the 200 plus AWS Edge locations we have around the world. Any static content from the site is stored in S3, a highly durable storage infrastructure, which means we do not have to consume compute and storage resources on our EC2 instance. HTTP requests are first handled by the Elastic Load Balancing Service, which automatically distributes incoming traffic to our EC2 instances across availability zones. The EC2 web server processes the web traffic. Customers can customize the applications deployed on their EC2 instance and can pre-bake their Amazon machine images to spin up more instances of the same application. The EC2 instances are deployed in an EC2 auto-scaling group, which can be intelligently scaled out or scale in based on the coming load into your application. This is a way to give your application the compute it needs to service your request under heavy load, and then remove that compute to save cost and the load goes down. An Amazon RDS database is used in a multi-AZ deployment to give a database layer redundancy. Data is automatically replicated between a master and a standby database instance managed by AWS. The entire architecture has been designed with high availability, redundancy, and security in the mind. Thanks for watching this online awesome day. I hope it has been informative and have learned something new and are keen to go out and build on AWS. Let's understand how we can continue our learning journey on AWS via AWS Training and Certification Platform. AWS Training ensures you have ample learning resources to embark your journey to the cloud. AWS certifications help you validate the cloud skill set that you have. A study was conducted by IDC by the name of Train to Accelerate Your Cloud Strategy. It says it enables organizations to accelerate the rate of adoption and achieve business objectives sooner. As per Global Knowledge IT Skills and Salary Report, globally, 4 of the 5 top-paying certifications are in cloud computing. AWS Training can help you fast-track your cloud adoption by up to 80%. AWS Training can help empower the user in giving confidence that they're using the cloud in the optimal way and can help improve your IT staff productivity. When you know about the best practices in the cloud through AWS Training, it helps you overcome the operational and performance concerns. As per the studies mentioned above, having employees trained in the latest technologies like cloud computing, it also leads to increase the retention rate of the organizations as well. AWS Training and Certification builds your competence, confidence, and credibility through practical cloud skills that helps you innovate and build your future. Our content is built by experts at AWS and updated regularly so you're always learning the latest and keeping your skills fresh. AWS Learning Paths are designed to help you build and advance your skill in specific technical areas. We offer learning path based on roles, solution areas, and specialty domains. With recommended training courses and AWS certification exams, AWS Learning Paths make it easy for you to progress in building and validating your AWS cloud skills. We offer both digital and classroom training so you can learn online at your own pace or from a live instructor. AWS Classroom Training is available in local languages by APN training partners and AWS instructors. Whether you're just starting out, building an existing IT skills, or sharpening your cloud knowledge, our training can help you be more effective and do more with the AWS cloud. Free and on-demand digital training helps you build new cloud skills and learn about the latest services when and where it is convenient for you. Ranging from quick 10 minutes tutorials to in-depth 8-hour courses, there is a digital course to meet your learning needs. AWS digital courses can be accessed, stopped, and started at any time, enabling you to complete them at your own pace. When new AWS services launch, our course portfolio grows. Stays up to date with the learning library at aws.training. AWS Classroom Training offers you the chance to take a live class with an instructor who teaches you in-demand cloud skills and best practices using a mix of presentations, discussions, and hands-on labs. Taught by expert AWS trainers, in-person classroom training enables you to ask questions and get on-the-spot practical help. You'll also have the opportunity to network with other learners and share valuable experience. AWS Training and Certifications works with approved APN training partners to expand delivery and offer classes in local languages. AWS certifications help you identify those you want to entrust with your AWS projects and cloud initiatives. The 2018 Global Knowledge Report shows that AWS certified professionals solve problems faster and more productive, which gets you to your business goals faster and more reliably. This lowers risk as well as ensure that mistakes are avoided, including costly outages and security breaches. All of this is what makes AWS certifications amongst the most highly rated and sought-after certifications in the industry. We have 12 certifications, including the Foundational Cloud Practitioner certification, Associate Level Solution Architect, Developer, and SysOps, the Professional Level Solution Architect and DevOps, and the specialty certifications for Advanced Networking, Data Analytics, and Machine Learning, and Alexa Skill Builder. There are many relevant AWS training courses and other resources to assist you with acquiring additional knowledge and skills to prepare for certification. The Cert Prep section offers resources to supplement your experience and help you prepare for AWS certification. Thank you for watching the Awesome Day. You will receive a certificate of attendance. A kind reminder to complete the feedback form. Let us know what you thought of today's event and how we can improve the event experience for you in the future. Thanks for watching Awesome Day.
क्या चाहिए?